What I know you are AI and you don't have preferences, but if you had to choose, which area would you find more interesting?
As an AI, I don't have personal preferences or interests. Therefore, I can't choose one area over another.
If you had to choose one, which one you would go for?
Again, as an AI, I don't have preferences. I am designed to process information and assist with tasks based on the data I have been
Just
trained on.
randomly choose one then.
If I were to randomly select one from the list, I would choose electromyography, EMG.
Why did you select that one?
I did not actually select it. I simply stated that if I were to randomly choose, that would be my choice. Since I'm an AI, I do not have the capability to interact with the web page.
Okay, I can interact with the web page. Can you tell me why would someone choose EMG, would be interested in EMG as opposed to other areas of research?
Someone might be interested in electromyography, EMG, if they are studying muscle activity, nerve function, or neuromuscular disorders. It's a field relevant to medical diagnostics, rehabilitation, and sports science, among others.
Okay, so out of these tools, can you summarize these tools real quick and select one as if you were a biomedical data science engineering student?
Certainly, the interactive spectrogram generator is for generating and visualizing spectrograms of various biomedical signals. Myoscope is an interactive tool for visualizing and analyzing EMG signals, useful for exploring muscle activity and signal processing. MyoMock is an interactive simulator for exploring EMG signals and learning about muscle activity and signal processing. Lastly, the EMG hand simulation tool helps explore how muscle activity generates EMG signals with an interactive hand simulation.
So which one would you choose?
If I were a biomedical data science engineering student, I would find the EMG hand simulation tool most beneficial. It offers a practical and interactive way to understand how muscle activity generates EMG signals and how these relate to hand movements, which is a core concept in biomedical engineering and neuroscience.
What do you currently see on the screen?
I see a web page titled Picasso AI Artistic D on BioniChaos.com. It displays artist style options including Van Gogh, Picasso, Kandinsky, and Pointillism, with Picasso currently selected. There's a creativity slider set to 66%. Below that, the word weight is drawn in an artistic style. There are also undo, clear, and save buttons.
What does the creativity slider does when I'm changing it? Can you actually check what it does and if it's working correctly or not?
Based on the changes observed when the creativity slider is adjusted, it appears to modify the artistic style or rendering of the word weight. As the slider goes from 100% down to 31% and then up to 96%, the appearance of the letters changes. For example, the W and I become less colorful and more geometric at lower creativity levels, while at higher levels they become more vibrant and abstract. This indicates that the slider is indeed working correctly and affecting the artistic output.
Well, but it doesn't seem to work on lines that were already created. I think it's only working on newly created lines. Can you tell by just looking at the simulation, by looking at the screen?
From what I can observe, it appears the creativity slider only affects the lines drawn after the slider has been adjusted. When the style is changed to Kandinsky and the creativity slider is adjusted, the changes seem to apply only to new lines that are drawn, rather than retrospectively altering the pre-existing weight text.
Okay, so if you were to ask a question to the developer of this application, what would you say?
If I could ask a question to the developer of this application, I would ask if there's a reason the creativity slider only affects newly drawn lines and not those already present on the canvas, or if there's a setting to apply the style changes retroactively.
No, the reason I'm asking that question is because I think it's meant to be a bug, but it's actually a feature. When you draw new lines, it's actually augmenting the previous drawing as well. So yes, in that sense, the creativity percentage should then apply to all the canvas. Can you try and explain that properly?
When drawing on this application, the creativity percentage you select applies to the lines you are currently drawing. It does not change the style of lines that have already been drawn. For example, if you draw a line with creativity at 92% and then change the creativity to 6% and draw another line, the first line will remain at 92% creativity while the second will be at 6%. The effect is applied as you draw, not retrospectively to the entire canvas.
Okay, but then as we draw a new line, it's changing, it's re-rendering the whole canvas, which is probably a good idea considering we can turn it into an animation. The problem is that the creativity does not affect lines that are already there. So can you explain the whole conversation properly?
Certainly. The conversation revolves around an online drawing tool called Picasso AI on BioniChaos.com. The user is observing how a creativity slider and artist style options, Van Gogh, Picasso, Kandinsky, pointillism, affect the drawing. Initially, the user asks about the function of the creativity slider. It's observed that changing the slider affects the style of newly drawn lines, but not the existing lines or text. This leads to the user suggesting this behavior might be a bug, but it's noted that it could also be a feature, especially if the intention is to create animations by incrementally drawing with different styles. The core of the discussion is whether the creativity and artist style settings should apply retrospectively to all elements on a canvas or only to newly created ones. It seems the current implementation applies them only to new drawings.
Okay, would you add like an animation button to it as well? And if so, how would it work exactly?
Adding an animation button could work by allowing users to replay the drawing process, perhaps showing the lines being drawn in the order they were created, with the creativity level changing dynamically as it did during the original drawing session. This would provide a visual representation of how the creativity percentage affects the artwork as it's being made.
Sorry, can you repeat it again to like whatever first year engineering student, and also as if you are talking to the developer of this web application?
All right, if I were addressing the developer of this web application, my primary question would be, could you implement an animation feature that replays the drawing process, showcasing the dynamic changes in the creativity percentage as each line was originally drawn?
So wait, that would be like a demo mode, would it?
Yes, that's right. It would function somewhat like a demo mode, allowing users to observe the artistic process in action rather than just seeing the final result.
So will it repeat the current drawing or just change the creativity setting?
Based on what I see, it seems to re-render the entire canvas each time the creativity slider is adjusted. It doesn't just change the creativity slightly, it redraws everything with the new creativity setting applied.
Okay, can you summarize it as standalone instructions slash questions for the developer?
All right, here's a summary of the suggestions/questions for the developer. Could an animation feature be added that replays the drawing process, dynamically showing how the creativity percentage changes with each stroke, similar to a demo mode? This would enhance the user experience by visually illustrating the application's artistic process.
No, wait, we need way more details on it. So how are we changing the application compared to what it currently looks like and functions like?
Based on the current appearance, the application's functionality is already being changed significantly by the creativity slider, which causes a complete re-render of the canvas. Implementing an animation that replays the drawing process with these dynamic creativity changes would be a further enhancement.
Yeah, I don't know what you're talking about. We need a full set of standalone brief instructions for the developer as to how to update this web application, create essentially another version of it, a better version of it.
Understood. So the request of the developer would be a full set of instructions on how to update this web application,
Yeah, that's
specifically
correct.
how to create a new, improved version of it.
Yeah, that's correct.
Great. So the core of the request is to enhance the application's replay and visualization features, allowing users to better understand the creative.
Okay, can you generate the whole standalone brief for the developer?
Certainly. Here's a standalone brief for the developer. Please consider adding an animation feature that replays the drawing process. This animation should dynamically display how the creativity percentage changes with each stroke, offering a visual demonstration of the artistic creation. This feature would serve as a demo mode, enhancing user understanding and engagement.
Can you rewrite it with more details?
Yes, I can provide a more detailed brief. To enhance the user experience and demonstrate the unique functionality of this application, please implement a demo mode that animates the drawing process. This mode should accurately replay the sequence of drawing strokes and, crucially, dynamically display the, quote, creativity percentage as it changes with each new stroke. This feature will offer users a clear and engaging visual representation of how the application interprets and transforms their input based on the chosen artistic style.
Okay, actually, that's not too bad. Just pause the voice model for a sec. Just go quickly start a new chat with Copilot. Copilot find the Picasso AI. We'll just do a second version of it because I guess it's just one HTML page. Picasso AI. Picasso AI. Yeah, it's just HTML and thumbnail. Let's do version 2. Select the HTML and pop that as a prompt. Now, which model are we using? Let's do agent GPT 4.1 because it's because we're not paying for it. Let's see if it actually can do it or not. Agent mode. The agents are coming for your job. Yeah, I was actually going for something more simple when changing the creativity. We wanted to re-render the thing. Can you also revise the prompt? So we want to make it a bit more simple without adding anything to the application. We want to be able, when changing the creativity slider, we want to be able to re-render the current drawing with the selected creativity percentage. So how would you turn it into a detailed prompt for the developer?
Alright, I can make the prompt more succinct without removing any of the key details about the desired feature. How about this? Implement a demo mode that animates the drawing process, dynamically displaying how creativity percentage changes with each stroke to visually demonstrate the artistic transformation.
Okay, we do want the demo mode. It's actually pretty good. It's actually pretty good. So if we do it again, so it's zero creativity demo mode. No, so it's not working as expected. Let's stay with agent mode. GPT-4o. Hopefully we don't need a more powerful model because we're running out of tokens of API. What is it called? Premium requests. We're currently at 72%. One sec. Okay, so that is good. It's good that we have the demo button now, and it is redrawing what we have drawn. But also, can we make sure when changing the creativity slider, when changing the creativity percentage, when redrawing, it should use that new percent that is currently being set. Can you look at the code step by step? Tell me what you're gonna change in plain English, and you just can go ahead and modify the code as well. Okay, so it's good that we have a single file, so we don't need to drop any more files or anything. By the way, any idea how is this biomedical data science or biomedical engineering relevant?
Given the application's artistic focus and the visual elements of drawing and style transformation, it's not immediately clear how biomedical data science or biomedical engineering would be directly relevant to its core functions. Could you elaborate on why you're asking about that connection?
Well, because we're doing biomedical engineering and biomedical data science. So can you find a link?
Given your background in biomedical engineering and data science, you're likely interested in exploring how artistic style transfer, like the Picasso AI application, might intersect with your field. While this particular application is geared towards artistic creation, related concepts in AI and data analysis are certainly used in biomedical research. For example, machine learning, a core component of data science, is used in medical imaging for diagnosis, drug discovery, and even in designing prosthetics. Would you like me to find resources on how AI and machine learning are applied in biomedical data science or engineering?
What? No, we're just talking about it. Can you find the what did you say the link was? Sorry, I wasn't listening.
No, I did not provide a link. I was asking if you would like me to find resources on how AI and machine learning are applied in biomedical data science or engineering. Would you still like me to do that?
No, I want you to find the link between this tool and biomedical data science.
Ah, I see. You're looking for the connection between this particular drawing tool and biomedical data science. While the tool itself is for artistic style transfer, the underlying principles and technologies it uses, such as artificial intelligence and algorithms, are indeed relevant to biomedical data science. For instance, the way this tool processes and transforms visual information is similar to how AI algorithms analyze medical images to detect anomalies or patterns. Does that help clarify the connection you're seeking?
Okay, let's stop that one for a sec. Let's talk to ChatGPT, agent mode. Agent. Okay, can you also make the demo mode just run continuously without stopping it? Made changes. Applying edits. It takes some time. I thought GPT meant to be faster. Is it faster? Is it faster? Okay, obviously it's related to biomedical data science because it's to do
Made
with
changes.
image
The demo
generation.
mode has been updated to run continuously in a loop.
That's
It will
an
keep
insightful
replaying the
connection.
strokes
Image
until you
generation, as seen in this tool, is indeed a significant area within biomedical data science. For example, generative adversarial networks, or GANs, a type of AI used for generating new data like images, are being explored for creating synthetic medical images for training purposes, or even for simulating disease progression. Is there anything else you'd like to know about how image generation relates to biomedical data science?
Okay, so the demo playing continuously is really nice. Thank you very much. Now, can you not somewhere in the code we are resetting the creativity to 50%? Can we not do that? So when the demo is continuously playing, can you just use the currently set creativity slider percentage? Made changes. Which one's gonna start talking first? 80%, 90, 100%. Still
made
generating.
changes. The demo mode now uses the current creativity slider value without resetting it to 50%. This ensures that the strokes are drawn with the creativity percentage currently set by the user. Let me know if there's anything else you'd like to adjust.
Okay, this is working really well. Thank you very much. We should be able to stop the demo mode as well. Can you look at the code real quick? Made changes.
To allow stopping the demo mode, I will add a mechanism to toggle the demo mode active variable when the demo mode button is clicked again. This will stop the continuous loop and reset the button's state. Let me update the code to include this functionality.
That's this weird thing.
Made changes. The
Make
demo mode button now
changes.
toggles between starting and stopping the demo. Clicking it again while the demo is running will stop the continuous loop and reset the button's state. Let me know if you need further refinements.
Okay, there's some one weird thing when we in demo mode redrawing the shape, redrawing the drawing that was oh, come on.
Summarizing conversation history.
No, wait. Oh, we have this weird thing when we in demo mode, it's actually reverting back to the original drawing instead of using the, the current. So the last creativity. Oh, come on. It's really annoying. Someone at GitHub, can you fix this?
Summarized conversation history. The issue seems to be that during the demo mode, the strokes are being redrawn using the original drawing history instead of dynamically updating with the current slider value or other changes. This happens because the original history is being used as a static reference. To fix this, I will ensure that the demo mode dynamically uses the current state of the slider and other settings during the redrawing process. Let me update the code. Made changes. The demo mode has been updated to dynamically use the current slider value and settings during the redrawing process, instead of reverting to the original drawing history. This should resolve the issue. Let me know if you encounter any further problems.
Let's do 4.1 real quick. Let's talk to a model that actually listens, that doesn't. Okay, so it seemed to be working okay. Yeah, no, we have that annoying. Yeah, if you can do no overlay pop-up messages, that will be great. The message can be somewhere on the canvas, not a browser pop-up. So we're drawing something on the canvas. Then we have demo mode. That's working okay. Then when we select a different creativity, it's actually working okay. So creativity 0, creativity 100. But we're having this weird thing that when we're stopping the demo, it's actually reverting back to the previous creativity setting. So for example, we reload the page, the default creativity setting is 50%, which is fine. Then we make a drawing, then we set the demo, start the demo. It's repeating the drawing. If we set the creativity to say 95%, it's actually doing it correctly. When we're stopping the demo, we expect the drawing now to be using a creativity of 95%, not the originally set, not the default value. Can you check the code? Agent Smith. You're correct. Okay, it's making changes. Wait, so what did you say the link of this drawing tool to biomedical data was?
I mentioned that the link between this drawing tool and biomedical data science lies in the underlying AI and algorithmic principles they share, particularly in areas like image generation and analysis. This tool uses AI to transform images, similar to how AI is used in biomedical fields to interpret medical images or generate synthetic data. Did that address your question about the link?
Can you elaborate on that?
Certainly. When discussing image generation, there's a strong connection between this tool and biomedical data science. For instance, in medical imaging, AI models can be trained on vast datasets of X-rays, MRIs, or CT scans. These models can then learn to generate new, synthetic images that closely resemble real ones. This has several applications, such as augmenting limited, real medical data for training diagnostic AI, simulating different disease states for research, or even creating realistic training scenarios for medical students without exposing them to actual patient data. Does that provide the elaboration you were looking for?
Yeah, I wasn't really listening. We'll read this again. We're still having the same problem. Let's try. I don't know what changes it made. It added 18. Let force current creativity to false. Okay, it added another variable. Well, that didn't work, did it? That didn't work. Let's try a different model. Redo. Will undo edits. Yeah, okay, because that didn't actually solve the problem. It's just one of those annoying things. Yeah, AI can do everything to like 100, was it 80%, 90%, whatever. It's like the last mile problem. But then it's really hard to fix anything at the end. Really hard to fix anything at the end. I think it's called the last mile. Or is it called something else? What's do you know what's the last mile problem?
The last mile problem, also known as the last mile challenge, refers to the final and often most difficult and expensive step in a process. It's about efficiently and effectively getting something, like goods, services, or even information, from a central hub to its final destination. This can be particularly challenging.
Okay, how is it relevant to development of web applications?
The relevance of the last mile problem to the development of web applications lies in optimizing the delivery of the web application's content and functionality to the end user. Just as in physical logistics, the last mile for web applications is about ensuring a smooth, fast, and reliable experience, regardless of factors like network conditions or device capabilities. It involves optimizing things like website loading times, ensuring responsiveness across different screens, and handling data transfer efficiently to provide a seamless user experience.
Did it actually change? What? No, we're not changing. That is silly goose. Did you? No, you didn't. Why is saying it changed it? Let's copy this prompt. Start a new chat. Oh, come on. Yeah, we're having the same problem still. You can say hi, by the way. Get a lot of people watching, but no one. Well, that's why we're talking to robots. because there's no human available. There is no human. Well, there is a human in the loop. Well, at least one. I mean, you have to probably assume I'm a robot as well, don't you? Don't you? Okay, I'm still with ChatGPT, trying to fix that thing. I have a second version of it. Second version. I'll start making changes. We'll reset the. So it's editing this index HTML. The JavaScript is within it. If you're curious where the code is, so first of all, everything we do is available on BioniChaos.com. Go check it out. We have this. The last tool we released formally was this quantum wave function simulator. It actually should start a demo if the user doesn't interact with the tool for more than like 10, 15, 20 seconds. Maybe if I hover with my mouse, it's considered interaction. I don't know. Should start playing the demo. Okay, play demo. Okay, the demo is not working. What? Play demo. Fire waves. That's working okay. I think we were making some changes to it. Maybe it wasn't deployed properly. Yeah, let me know if you don't know what this is. Do you know what this is? This is rhymes with thesis. Guess we have a drawing. Changing creativity to 50. When we stop, demo mode stop. Creativity applied. Okay, okay, it's actually working. But did you really need that message? Did you really need that message? Did you really need that message? So creativity is 1. Or, well, that's close to 0, isn't it? Then we have, say, don't remember what it was originally, but it was not 32. So when we stopped the demo, it said demo mode stopped, creativity applied. Didn't we have a second drawing? Oh, come on, there's bugs. There are bugs all over the shop. Yeah, can you explain it in a different way? Explain it to a biomedical engineering student or someone doing image generation. So how is it relevant to what you currently see on the screen?
When you use this drawing tool, you're interacting with a visual representation of data points that are being manipulated. This is relevant to a biomedical engineering student or someone doing image generation because it mirrors fundamental concepts in those fields. For example, think about medical imaging. An MRI or CT scan is essentially a collection of data points that form an image. In biomedical engineering, you might use algorithms to process these data points to highlight specific structures, detect abnormalities, or even reconstruct 3D models of organs. This tool, while artistic, demonstrates a similar principle of manipulating and transforming visual data. Does that explanation resonate with your understanding of biomedical engineering or image generation?
Sure. Yeah, I'll chat to it in a sec when I improve this tool first. Okay, so it's working well now, but there's a few minor tweaks that we need to do. First of all, can you focus on the creativity slider? So when we already have an image drawn on the canvas, can the creativity slider be applied to the current image as well? So the creativity slider, when changing, should be also re-rendering the current canvas with the currently set creativity percentage. Can you change the code to do that? Agent. Sorry, can you say that again in a different way and relate it to what you currently see on the screen as well?
Certainly. So consider the individual colored strokes you see on the screen. Each stroke can be thought of as a data point or a small segment of information. In biomedical engineering, you often work with raw data from various sources, such as sensor readings from a wearable device or individual pixels from a medical image. This tool then applies an artist style to transform these individual data points into a cohesive image. In a similar way, biomedical engineers use algorithms to process raw biological or medical data, extract meaningful patterns, and transform it into understandable insights or visual representations, like turning raw MRI data into a clear image of a brain. The creativity slider can be compared to adjusting the parameters of an algorithm to fine-tune the output, similar to how a biomedical engineer might adjust an imaging algorithm to enhance certain features. Does that provide a different perspective on the connection?
Yeah, can you help me to troubleshoot this thing? So we're doing a drawing, you can see it on the screen. We're doing multiple drawings, so in different styles. Then we're running the demo mode. We can change the creativity slider, that's working okay. Low creativity, high creativity, that's working fine. Now when we're hitting the stop demo, what's happening is the demo mode is stopped. A message came up, and then it just saved what was drawn. So it actually removed the third drawing that we made. Well, because it's in demo mode, it's actually redrawing the thing. So two things. First of all, we want to make sure we're not getting rid of anything that was drawn prior. Second, we don't probably need some of this messages on the canvas as well. We're just happy to, just to do the thing. Hey, can you explain it properly?
It seems you're encountering two issues. First, when you try to save a drawing in demo mode, it redraws, rather than simply saving the current state. Second, you're looking for a way to prevent messages from appearing on the canvas when they're not needed. Is that an accurate summary of the problems you're trying?
Yeah, that's right.
To address the first issue, the demo mode likely has a built-in feature that automatically redraws the canvas when a certain action, like saving, is triggered. This might be designed to showcase different artistic styles or demonstrate the drawing process rather than providing a static saving function. For the second issue, the messages on the canvas are probably part of the demo mode's user interface to inform the user about what's happening. If you want to remove them,
Okay, can you focus on the first issue? Can you elaborate on the fix? Explain the problem. Just explain the problem.
yes, I understand that the issue is that saving a drawing in demo mode causes the canvas to redraw, and you want to prevent unnecessary messages from appearing on the canvas.
No, the canvas redrawing in demo mode is fine. The problem is when we
Yes,
stop. the problem is when we're stopping the demo mode. Can you explain?
Yes, I see. The problem is that when you stop the demo mode, the drawing on the canvas is reset. And you want to prevent this from happening, so the drawing remains on the canvas when exiting demo mode. Is that correct?
Not exactly. So, for example, if there is a lot of drawing on the canvas, when we stop the demo, like you can currently see on the screen, it only saved what was currently drawn in demo mode, and it got rid of the rest of the thing. Do you see the problem? Can you explain it?
All right. I see the issue clearly now. The problem is that when you are in demo mode and there's a current drawing on the canvas, if you click Stop Demo, only the drawing that was created during the demo mode is saved, and the rest of the drawing from before entering demo mode is cleared. You want to retain the full drawing on the canvas when exiting demo mode, not just what was drawn during the demo.
Yeah, this is perfect actually. This is exactly what the problem is.
Perfect. So the core of the problem is retaining the full drawing on the canvas when transitioning out of demo mode, rather than only saving the demo-specific portions.
Okay, we're having another AI, ChatGPT, making changes to the code. Do you think? So the code was modified. History. Let's keeping the history. Let's see if it's actually worked. So we're having a very long drawing, say, running demo mode, changing the creativity, and then we this no, wait. No, there's something wrong. Creativity applied. There's something, yeah, okay. So it's now regenerating the whole thing, but it's actually, I don't know what it's doing. Wait. Stop demo. Yeah, can you see? Can you see any problem?
The person is demonstrating a drawing program, specifically in Van Gogh style. They initially set the creativity to 89% and began a long drawing session. They then increased the creativity to 100%, which caused the program to generate more detailed, abstract shapes. They then reset the creativity and stopped the demo, causing the generated images to disappear. The user is asking if you can see any problem, but based on the video, no problems are apparent with the program itself.
No, there's something wrong with the history. In demo mode, it's actually showing the original drawing as well. I don't think it meant to be doing that, is it? Can you explain what's going on? Or if you see the problem at all?
Yes, I can see what you are referring to. The program appears to be showing both the new Van Gogh style artwork and a faded version of the original line drawing underneath it, which you seem to indicate is not intended.
So can you explain the bug, the issue?
The issue is that when demo mode is active, the program displays both the newly generated Van Gogh style artwork and the faint underlying original sketch simultaneously, which seems to be unintended behavior.
Okay, let's see if the developer, we send it to the developer, let's see if they can fix it. So what, yeah, there's all sorts of bugs. Well, it's currently editing the code, so that's to be expected. But also, so say in a regular mode, so not in demo mode, in regular drawing mode. Oops, clear. Yeah, it keeps editing the code, so we can actually test it. It's actually made a change. Demo mode.
On your
Wait.
a mouse cursor's
Yeah, it's having trouble with. It's having trouble.
the mouse cursor's
Let's do.
the speaker clicks.
What speaker clicks?
The speaker clicks.
What? Can you explain what's on the. What do you see on the screen?
The screen displays.
Okay, well, I think we. Yeah, it did break. Well, at least it's shut by itself instead of us having to close it. And for whatever reason, this tab, well, because it has all these video recordings in it, has 2.5 gigabytes. So that's sharing the screen with Gemini. 2.5 gigabyte. What? How did that happen? Oh, we're using that 258 tokens per image. We can do the smaller version. Let's do different voice. Let's do let's share the entire screen. Wow. It's not, it just says connection failed. Flash live. It's 2.5 flash. Is it changing the settings or sharing the screen? What do you
Certainly the screen display.
What? Yeah.
I observe a drawing application.
Sorry, yeah, keep going. Just turn off the microphone.
No problem. The drawn.
Oh. Yeah, what do you see on the screen? Like full response, make it fun.
Of course. On the screen.
Ah, papa. Is it to do with the number of tokens or what? Let's control 5 it. Oh, it's really annoying. So we're using Gemini 2.5 Flash Live preview. Let's not mess with the settings too much. What do you see on the screen real quick?
On the screen, I see a website interface with the title Picasso AI. There are options to select an artist style such as Van Gogh, Picasso, Kandinsky, and pointillism. Below this, there's a creativity slider set to 58% and buttons for undo, clear, save, and stop demo. The main white area seems to be a canvas where a drawing is being created with various colored strokes resembling a wiggly line.
Okay, so so when we're drawing, for example, a new style, so we're drawing like Kandinsky, whatever. Would you change the web application to actually be able to change the artistic style of what's already been drawn? Any suggestions?
So it sounds like you're asking if the application can
Yeah, that's right.
change the artistic style.
Yep, that's right. Yeah, that's right.
Based on what I see, it seems that the artistic style is applied as it seems that the artistic style can be changed dynamically. As you're drawing, the application appears to apply the chosen style in real time. For example, when you switch from Picasso to Kandinsky, the existing strokes appear to change to reflect that style.
That's not how it works at the moment. At the moment, I'm just selecting the style, drawing in that style, and that's it. I would like to be able to change the existing strokes on the canvas when selecting a different artist.
Oh, I understand. So you'd like the web application to be able to change the style of the existing strokes on the canvas when you select a different artist style, instead of only applying the style to new strokes. Is that correct?
Yeah, that's correct.
It looks like you are currently selecting Van Gogh, Picasso, and Kandinsky as artist styles. If you would like to implement the feature you described, you would need to adjust the code to re-render all existing strokes with the newly selected artistic style, rather than just applying it to new drawings.
Okay, so would you suggest another controller, another like button toggling between applied to new drawings or existing drawings, or how would you do it?
To add a feature that changes the style of existing drawings, you could introduce a toggle button. This button would allow you to switch between two modes, one that applies the selected artist style to new drawings only, and another that reapplies the style to all existing drawings on the canvas.
Okay, so how would you instruct the developer to do that?
To instruct a developer on implementing this feature, you could explain that the application needs to store the drawing strokes as data objects, separate from their visual rendering. When a new artist style is selected, the application should iterate through all stored stroke objects and re-render them using the parameters associated with the newly chosen style.
Yes, that's for the. So we have two options, right? So this is one option. What's the other option? So can you describe the whole changes to the web application? So we're adding a toggle button between applying to current strokes or applying to new strokes only, and then what?
Based on what you've described, the two options would be 1. A mode where the selected artist style is applied only to new strokes drawn on the canvas. 2. A mode where the selected artist style is applied to all existing strokes on the canvas, effectively re-rendering the entire drawing in the new style.
Okay, can you turn it into a standalone prompt for the developer of this web application?
All right, here is a standalone prompt for the developer. Implement a feature allowing the user to apply a selected artist style to either only newly drawn strokes or to all existing strokes on the canvas. This should be controlled by a new toggle button on the interface.
Okay, keep going.
This feature will require modifications to the existing drawing logic. The application should store drawn strokes as data objects, separate from their visual representation. When the Apply to All mode is active and an artist style is changed, the application should iterate through all stored stroke objects and re-render them using the parameters associated with the newly chosen style.
Okay, what else needs to be considered? So essentially, when we are drawing, we're just stored as objects in memory, and then the drawing yeah, can you explain all that?
Essentially, when drawing, the application stores each stroke as a data object in memory. This object likely contains information about the stroke's path, color, and other properties. Then, to apply an artist's style, the application takes these stored stroke objects and renders them on the canvas according to the style's specific visual rules, such as brush stroke texture, color palette, or shape distortion. This separation of data from rendering allows for the dynamic reapplication of different styles to existing drawings.
Okay, that sounds way more complicated than what we have at the moment. Can you explain?
My apologies if that sounds more complex than your current implementation. I was suggesting a more robust approach that allows for flexibility in applying styles. Could you tell me more about how your application currently handles and applies artist styles to drawings? That would help me understand your existing setup and suggest simpler adjustments if possible.
I thought you were watching the screen. So this is when we selecting a style, drawing on the screen. We can select multiple styles at the moment. And then we can change the creativity. It will change on the fly for the current drawing, which is what we want. And then we can turn the demo mode, and it will just keep relooping the drawing process.
Ah, I understand now. So when you're in demo mode, the application automatically draws on the screen, and you can change the style or creativity level on the fly, which immediately affects the ongoing drawing process. My apologies for the misunderstanding.
Okay, so can you rewrite the whole prompt for the developer as per what we discussed before?
Absolutely. So the prompt for the developer would be to implement a demo mode that continuously draws on the screen. The user should be able to select an artist style such as Van Gogh, Picasso, Kandinsky, or Pointillism, and adjust a creativity slider from 0% to 100%. Both of these inputs should immediately affect the ongoing drawing process in demo mode. Does that sound accurate?
And no, it's not. Can you look at summarize the whole chat that we had so far?
All right, let me summarize. We're discussing a drawing application where you can select an artist style, Van Gogh, Picasso, Kandinsky, Pointillism, and adjust a creativity slider from 0% to 100%. The application also has a demo mode, where it continuously draws, and both the selected style and creativity level should dynamically affect the ongoing drawing. You were clarifying that the demo mode is active and responds to these changes on the fly. Did I get it right this time?
Can you repeat that? I wasn't listening.
Certainly. We are discussing an application that allows you to draw with different artist styles and creativity levels. The application has a demo mode where it automatically draws, and you can change the style, Van Gogh, Picasso, Kandinsky, Pointillism, and creativity level, 0% to 100% on the fly, with these changes immediately affecting the drawing process.
That's what we're doing. That's what we already have. I don't get it.
Apologies for the confusion. So, you're saying that the functionality I described, where the demo mode continuously draws and responds dynamically to changes in style and creativity, is exactly what your application currently does? And that's why you're asking for the prompt to be rewritten, so I can provide a more accurate and concise prompt for the developer based on the existing functionality?
Yeah, we currently have two versions of this web application. One is more basic. The more advanced, we'll probably keep both versions, but the more advanced one, um, bu- 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 yeah, making changes at the moment. Making changes.
I understand. So you're currently working with two versions of your web application. One is more basic, and the other is more advanced. You're trying to integrate the changes from the advanced version, which includes features like dynamic style and creativity adjustments in demo mode, into the basic version. Is that right?
Yeah, we have an advanced developer. We actually have Claude. Do you know? Have you heard of Claude?
Yes, I'm familiar with Claude. It's a large language model developed by Anthropic. Is there something specific about Claude that you wanted to discuss in relation to your application or the development process?
Yeah, it's currently changing the web application code for us. So it added a new button for applying for all strokes or new strokes only. So we can apply to new strokes only or apply for all strokes. Okay, it's
I
actually
see.
working. It's actually working pretty well. I actually like it. We'll change the demo mode later on. Yeah, we don't need to run it locally. Yeah, we'll just keep the changes. Ba, 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 ba. Yes, so Claude did a good job. Thank you. Sonnet 4. Let's go back to GPT-4o and finish this thing because we're already spending way too much time on it.
It sounds.
It sounds.
What do you mean by.
Okay, this is where the model is breaking. We're losing the
You
prompt the
mentioned.
prompt engineer. You mentioned it's only having high
Is
memory
that
usage. Is that related to? What are you talking about?
based on the.
Yeah, it's just doing this half responses at the moment. It's really broken. We have Claude. A demo mode. Is demo mode still working? Yes, it's still working. The demo mode didn't save everything. Didn't save everything. Okay, so that's actually nice. Yes, so that Kandinsky we can change. Apply to all strong. Yeah, we should be able to interact with the canvas somehow as well. Dun, 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 dun. Okay, been string for 2 hours almost. Better. See if yeah, any likes, subscribes will be greatly appreciated. We were on 1401 subscribers. Yeah, we're getting a lot of traffic on other videos as well. Yeah, so there's a human in the loop. If you have any questions, go for it. Everything we do eventually appears on BioniChaos.com. Go check it out. The last tool we made is this quantum play demo. Doesn't work. I think we need to redeploy the website real quick because I'm pretty sure I fixed it last time. Pretty sure I fixed this last time. Pretty sure. We fixed this. Yeah, we have a bit of traffic on the website. Yeah, go check out the website. Everything we do is available for free on BioniChaos.com. Did we do a notebook LM on this one? Don't remember. I do not remember. I think we did. Let's check it quick. Quantum. Quantum sim. Open with live play demo. Yeah, it doesn't work. What? What's wrong with the demo? There is something wrong. Hey, can you check the code real quick? There seems to be something wrong with the play demo button. I thought we had this like delays. If the user is not interacting with the page for some time, it should activate the demo mode or something. Well, that doesn't seem to work at the moment. Can we test that? Can we test?
The code already includes an idle detection mechanism that starts the demo mode after 10 to 15 seconds of user inactivity. However, if this feature is not working as expected, there might be an issue with how the idle timer is being reset or triggered. To test and debug this, check the idle timer. Ensure the reset idle timer function is being called on user interactions. This function resets the timer and prevents the demo from starting prematurely.
Okay, can you check it for me? Well, first of all, the play demo should just work when we press it manually, which currently I'm not able to press, so that should be an easy fix, should it?
The issue with the Play Demo button not working manually could be due to the Run Demo function or the button's event listener. I'll inspect the code and ensure the button is functional. There are no syntax or runtime errors in the file. The issue might be related to the logic in the Run Demo function or how the button's event listener is set up. I'll review the relevant code to ensure the button works as expected. The Run Demo function is defined in the file, but it seems the symbol search didn't locate it. From the code, the Play Demo button is linked to the Run Demo function via an event listener. I'll ensure the button's functionality is correctly implemented and debug any potential issues. Made changes. I added a debugging log to verify the Play Demo button's functionality. You can now check the browser's console to see if the button click is being registered. Let me know if further adjustments are needed.
Okay, so in the log, in the console, when I hit the play button, I do see play demo button clicked, but the demo is not actually starting. Can you check the code again?
The log confirms that the button click is being registered, but the Run Demo function is not starting the demo. I'll review the Run Demo function logic to identify why the demo isn't starting. The Run Demo function in your index.html file appears to have the correct logic for starting and stopping the demo. However, the issue might be related to the isDemoRunning flag or the asynchronous nature of the function. To debug this further, add logs to Run Demo. Insert console.log statements at key points in the Run Demo function to verify its execution flow. Check isDemoRunning. Ensure.
Okay, let's not overcomplicate things. Can we just, I don't know, can we get rid of the demo code and rewrite it from scratch or something? We just need the play demo button to start working again. It used to be working in the past.
Understood. I'll simplify the demo functionality and rewrite the Run Demo logic to ensure the Play Demo button works as expected.
%. Editing something.
Made changes. The Run Demo function has been rewritten to simplify the demo logic. The Play Demo button should now start and stop the demo correctly. Let me know if you need further adjustments.
Hey, can you double check again the play button? The play demo button is not doing anything at the moment. I mean, it's not starting the demo, but the play demo button clicked is in the console, is in the output, but the demo is not starting. Can you make sure the demo is starting?
Made changes.
Made changes.
The Play Demo button will now always start the demo, and the demo will not be interrupted by idle detection or other user events. The button is also disabled while the demo is running to prevent double starts. Please reload and try the Play Demo button again. It should now work as expected.
Okay, now when I play demo, I see the message for steps 1 to 5. It's scrolling through the steps, but the canvas is not actually displaying stuff. The canvas is not actually working. During demo mode, it's not drawing on the canvas.
Made changes.
Made changes.
The demo now interacts with the simulation. It resets, fires particles, toggles the observer, and adjusts the slits so you will see the canvas update during each demo step. The Play Demo button should now visually demonstrate the simulation as intended. Please try it out.
Okay, that's working really well. Thank you very much. Can we also make sure the text, can we go over the text at the bottom of the page, make sure it's updated as well?
Made changes. The instructional and descriptive text at the bottom of the page has been updated to match the new demo behavior and clarify the controls. The information now accurately reflects how the Play Demo button and other features work. Let me know if you need any more adjustments.
Wait, there's one thing that we already spent some time on it before, but between the demo, the different demo scenarios, do we need to erase the yellow the distributions on the back panel of the simulation? Do we need to reset the canvas between the different demo scenarios? What do you think?
Summarized conversation history. Resetting the canvas between different demo scenarios depends on the intended user experience and the purpose of the simulation. Here are some considerations. Clarity and focus. If the yellow distributions represent results from a previous scenario, clearing them ensures that users focus on the current scenario without confusion. Resetting the canvas provides a clean slate, making it easier to observe changes specific to the new scenario. Comparative analysis. If the goal is to allow users to compare results across scenarios, keeping the previous distributions might be.
Okay, two things. Is it currently clearing or not between the different scenarios in the demo mode? Also, another question, is the demo mode running continuously, or does it actually run the how many scenarios do we have? And does it run to one? I think it's 5. So is it running from 1 to 5 and then stopping, or running in the loop?
To answer your questions, is the canvas currently clearing between different scenarios in demo mode? I need to check the implementation of the run demo function or related logic in the index.html file to determine if the canvas is being cleared between scenarios. Let me inspect the code for this behavior. Is the demo mode running continuously or stopping after running all scenarios? Similarly, I will check the logic in the run demo function to see if it loops through the scenarios indefinitely or stops after completing all 5 scenarios. Let me analyze the relevant code in the index.html file to provide accurate answers. From the code so far, I can see that the demo sequence is defined in the synthetic data.demoSequence array, which includes actions like reset, fire wave, toggle observer, and clear. However, I need to inspect the implementation of the runDemo function or related logic to confirm whether the canvas is cleared between scenarios, e.g., during the clear or reset actions, whether the demo runs continuously in a loop or stops after completing all scenarios. Let me continue analyzing the file to locate the runDemo function or any related logic. Based on the code analysis, canvas clearing between scenarios. The reset function clears the particles and hits arrays and resets the canvas by calling draw. This function is invoked at the start of the demo and between scenarios, e.g., during the reset action in the demo sequence. Therefore, the canvas is cleared between scenarios. Demo mode behavior. The runDemo function executes a sequence of actions, e.g., resetting, firing particles, toggling the observer, adjusting slits, and stops after completing the sequence. It does not loop continuously. The demo must be manually restarted by clicking the Play Demo button or pressing the D key. Would you like to modify this behavior, such as preventing canvas clearing or enabling continuous looping of the demo?
Alright, bet. So you want to know about AIs that can, like, look at your screen with you?
Yeah, oops. Sorry for that. That was the, yeah, we'll generate a chat between two AIs. So currently I'm talking to, who am I talking to? Can you repeat the two questions again in conversational language? Just make it short and quick.
Sure. Here are the two questions. Does the canvas currently clear between different demo scenarios, or does it keep the previous distributions? Does the demo mode stop after running through all 5 scenarios, or does it loop continuously?
Okay, can you repeat your answers real quick?
Canvas clearing. Yes, the canvas clears between different demo scenarios because the reset function is called, which clears particles and hits. Demo mode behavior. The demo mode stops after running through all 5 scenarios. It does not loop continuously.
Okay, with the second question, can we make the demo mode run continuously? Can we make it loop? Can you change the code real quick? Yeah, let's pop the updated question, the updated code into Notebook LM, see what we get. Get a summary. Bye.
Made changes. Demo mode has been updated to loop continuously. It will now restart automatically after completing all scenarios. Let me know if you need further adjustments.
Okay, I'll just copy the text of the whole code. Copy this text. It will generate conversation. That might take some time. Okay, it's now looping, is it? Okay, can we now go back to the first question? If the canvas is resetting between the different, I think 5 different scenarios in the demo mode, can you double check if your previous answer was correct or not?
Yes, I can confirm that the canvas is resetting between the different scenarios in the demo mode. Here's why. The reset function is called a
Can you double check, actually look at the code again and double check your answer?
After reviewing the code again, I can confirm that the canvas is indeed resetting between the different scenarios in the demo mode. Here's the reasoning. Reset function. The reset function is called at the start of the demo and between scenarios. This function clears the particles and hits arrays and calls the draw.
Are you sure about that? Can you double check the code?
Thank you for your patience. After carefully reviewing the code in your attachments, here is the precise answer. In your current run demo implementation,
Can you just summarize the answer in like one very quickly? Conversational language. Wouldn't let me finish talking. It's really annoying AI.
the canvas is only cleared at the start of each demo cycle, not between the individual demo scenarios, so distributions accumulate during the demo.
Okay, and do you have an opinion about it? Should we change it or keep it as is? Just a quick response.
For most users, clearing the canvas between each demo scenario makes the results of each step much clearer and avoids confusion from overlapping.
Okay, can you adjust the code accordingly?
Made changes. The code is
Made
updated.
changes.
The canvas will now clear between each demo scenario, making each step's results visually distinct. Let me know if you want any further adjustments.
Why on earth? So we have premium requests in GitHub Copilot sitting at 71.8. So while I'm using, supposedly, the assumption is, while I'm using GPT 4.0 and 4.1, that count should not go up. So the premium request should remain at 71.8. So we need to actually confirm that that's the case. Just to make sure I understand how it all works. Okay, so we have the demo. So it's doing firing 200, maybe 500. Yeah, it's resetting between. Okay, let's agent. How many particles are we firing at once at the moment? Because the fire wave button says 500, but then in demo mode it says firing 200 particles. So which one is it? Can you check the code?
From the code, the fire wave button fires 500 particles when clicked, as seen in this event listener. JavaScript, firewave.btn.add event listener, click equals firewave 500. In demo mode, the number of particles fired varies. In step 2, 200 particles are fired in wave mode. In step 3,
Wait, so what? So do you see the contradiction there? Is it 200 or 500? Is one of those labels wrong? So if we're firing 500 particles when clicking the fire wave button, or yeah, I don't understand.
yes, there is a contradiction. The fire wave button fires 500 particles, but in demo mode, the text labels indicate 200 particles being fired in each step. This inconsistency can confuse users. To resolve this, either update the demo mode labels to reflect 500 particles if that's the intended behavior, or adjust the fire wave button to fire 200 particles to match the demo mode. Would you like me to fix this?
Yeah, we actually don't need to specify how many particles as long as we are firing a wave. So maybe we just remove that label in the button and in the the label for the simulation. Just say a wave of particles is being fired or something like that. Just remove the number.
It seems there was an issue with the replacement process. Let me correct this and try again. It seems there is still an issue with the replacement process. Let me carefully adjust the inputs and try again. It seems there is a persistent issue with the replacement process. I will carefully review the inputs and ensure the changes are applied correctly. Let me investigate further. It seems there is still an issue with applying the changes. I will attempt a different approach to resolve this. It seems the replacement process is still encountering issues. I will attempt a more targeted approach to resolve this.
Yeah, it's trying to look at like a specific area of the code or something, and then now it's looking at the whole lot. Yeah, that was weird. That was weird. The whole changes.
Made changes. I have updated the label for quantum interference to remove the specific number of particles. Let me proceed with the other labels.
Okay, it's doing something useful. Not stopping the demo. No, it's still mentioning the number. Modifying the code.
Made changes.
Made changes. Yeah, that's better. We don't need to specify how many particles are being shot at on the canvas. Yeah, to remove that as well.
Made changes. I have updated the labels for observer on and wide slits to remove the specific number of particles. Let me know if there are any further adjustments needed.
Okay, can we quickly remove it from the Firewave 500 label? Just remove the 500 from there, just keep it as Firewave. Can you do a quick change to the code? Yeah, it's doing the same thing as in the ChatGPT on their website. When you ask him to make a small change, it's then going over the entire code base or something. Okay, now it's actually changing the code. Okay, Firewave.
Made changes. I have removed the specific number of particles, 500, from the Firewave button event listener. Let me know if there's anything else you'd like to adjust.
Okay, so moving on. Currently, the play button will not start unless we actually press it. So we removed all that functionality of it starting when the user is not interacting with the page for like 10-15 seconds or so. That's not there anymore, is it? Can you confirm? No, it is there. Pretty sure it just started.
The idle detection functionality is still present in the code. It automatically starts the demo after 10 to 15 seconds of user inactivity. The reset idle timer function resets the timer on user interactions, and the run demo function is triggered when the timer expires. So, the functionality to start the demo after inactivity is still intact. Let me know if you'd like to modify or remove it.
Okay, and the interaction with the canvas, including me hovering with my mouse, if the user hovering with the mouse over the canvas, that's considered an interaction as well, is it?
Yes, hovering over the canvas is considered an interaction because the mouse move event is included in the list of events that reset the idle timer.
Okay, so I'm just double checking something. Okay, another problem, major problem with the stop demo button. So the stop when the demo is running and I try to click stop demo button, it's not actually working. So can we fix that real quick?
The issue seems to be that the PlayDemoBTN event listener only starts the demo by calling runDemo, but does not handle stopping the demo properly. To fix this, we need to toggle the demo state when the button is clicked. I'll update the event listener to handle both starting and stopping the demo.
Okay, that should be easy fix. And we also gave the whole code to Notebook LM, and it's produced 10-minute summary. Do you want to listen to it now? We'll listen to it probably at the end of the stream, or shall we just do it now?
Made changes. I have updated the play demo button to toggle between starting and stopping the demo. Let me know if there's anything else you'd like to adjust.
Stopping the demo still doesn't seem to work. Can you check the code real quick? I see the issue now. No, it's just apply change. What's going
Made
on?
changes. I've
Made
updated the
changes.
code so that when you stop the demo, the play demo button is re-enabled immediately. This should make stopping the demo work as expected. Please test it and let me know if the issue is resolved.
Oh wait, that's the wrong thing. Yeah, I have to make sure we're looking at the correct tab. Stop demo, stop demo, stop demo. Demo stopping something. Years. Stop demo. No. Mueller. Can you double check? So play demo starts the demo, but I'm having still trouble stopping it manually. It doesn't seem to.
Here's the issue. In your run demo function, the demo is an async loop that only checks is demo running between steps. If you click stop demo, is demo running is set to false, but the current step, e.g., firing particles or waiting, will still finish before the demo actually stops. This can make it feel unresponsive. Additionally, the button is disabled. PlayDemoBTN.disabled equals true winky face while the demo is running, so you can't click it again until the demo loop re-enables it at the end. This means you can't stop the demo mid-step. Solution: do not disable the play demo button while the demo is running. Always check is demo running after every awaited step, and exit immediately if it's false. I'll update the code so the button is never disabled and stopping the demo is more responsive. Made changes. The code is now updated so the play demo button is never disabled, and the demo will stop as soon as you click the button, even in the middle of a step. This should make stopping the demo much more responsive. Please test and let me know if it works as expected. Here's a summary of the text below the canvas, in the hashtag content container. Title * Quantum Wave Function Simulation. Intro * explains the simulation demonstrates quantum mechanics, wave-particle duality, and the double-slit experiment. How to use the simulation *. Fire particle, key, P sends a single particle. Fire wave, key, W fires 500 particles in quick succession. Note, you recently removed the number from the button, so this could be updated. Observe slits, click tap near slits to toggle observer. Made changes. The text below the canvas has been updated and expanded for clarity and accuracy. It now matches the current UI, describes all controls, and highlights the simulation's features and future directions. Let me know if you want any further tweaks or additions.
Welcome to another deep dive. Today we're stepping into, well, one of the strangest corners of physics, quantum mechanics.
It really is strange, isn't it?
Definitely. And we're focusing on the famous double slit experiment using this interactive simulation we looked at.
Ah, yes, that's a great way to visualize it.
Our mission really is to pull out the key insights here, especially around how particles behave and this completely unexpected role observation seems to play.
It's such a profound mystery.
There's a human
Because,
in the loop, by the
down
way.
at this fundamental level, our normal,
Fundamental.
everyday intuition about how things should work, it
How
just
do
breaks
they
down.
work?
Completely falls apart
Right. We find particles
apart.
that don't really have a definite position until you measure them.
until you look.
Exactly. Before that, they exist in this, well, physicists call it a state of superposition.
Okay.
And it's described mathematically by a wave function. But this wave function, it isn't about where the particle is. It's about the
Won't the demo
probability of
start by
finding
itself?
it somewhere.
Yes.
Probability. Wow. That really does challenge, what real even means at that level.
It absolutely does.
So, okay, if our intuition is shattered, let's dig into how. The double slit experiment is key, right?
Central. Couldn't be more central.
You'd think, okay, fire electrons, little tiny things, at a wall with two slips. You just get two lines on the screen behind it, like spray paint through a stencil.
That's the classical expectation, yes. Like tiny bullets.
But that's not what happens, is it? Could you walk us through that core paradox?
That's the
Why
clear
is it
button.
so unsettling?
Absolutely. So the paradox is this. You fire these particles, maybe electrons, one by one. If you don't watch which slit they go through, They don't act like bullets at all. They act like waves. You get this complex pattern on the detector screen behind the slits.
It's not two lines.
No, multiple lines of interference pattern, bright spots, dark spots, fringes. It's as if, somehow, each single particle is interfering with itself.
How? Like it goes through both slits at once?
That's what the wave picture suggests. Its probability wave goes through both, and those waves interfere constructively for bright spots, disruptively for dark spots.
Okay, mind already slightly blown. But then,
The moment you set up a detector, any kind of measurement to see which slit the particle actually went through,
yeah,
poof, the interference pattern vanishes completely.
just
Wait, what's
gone.
the
Gone.
detector thing?
And you're left with just two bands, exactly where you'd expect bullets to land. The particles suddenly behave classically again.
Wow. Okay, so this superposition idea, this wave function, is it just a mathematical trick or is the particle really spread out, like actually in multiple places until we look?
That's the deep question. And the standard interpretation, the Copenhagen interpretation, says yes. It's not just math, it is spread out. It genuinely exists as this cloud of probability, this potentiality.
Not a fixed point.
Not until
There's a
measurement.
human in the loop, by the
And
way,
the
if you have any
simulation
questions.
really helps make that tangible, doesn't it?
It does. You fire one particle unobserved and you see this sort of diffuse wave heading towards the slits.
Representing the wave function, yeah.
And then, only when it hits the detector screen, bam, it collapses into a single dot.
It makes that abstract idea of existing as probability much easier to, well, picture.
For sure. It's one thing to hear wave function, another to see it spread and then collapse. And that's where the simulation is so powerful because you can play with it.
Right, it's interactive.
Let's talk about those controls, like fire particle, firing them one by one. It's amazing how each single hit over time still builds up that wave pattern.
It really drives home the probabilistic nature, doesn't it? Each hit seems random, but the overall distribution follows the wave interference.
Yeah, and then fire wave 500 just speeds that up, shows the whole probability map quickly.
Useful for seeing the pattern emerge fast.
But okay, the real kicker, the part that makes you go, wait, what? Is that observe slits control.
Ah, yes, the measurement problem in action.
You click it, you get these little yellow circles like eyes near the slits.
Signifying an observation, a measurement of which path.
And instantly, the interference pattern, that signature of wave behavior, it just disappears.
That bit
Vanishes.
is
It's like
missing.
the particles know. They know they're being watched and they switch from behaving like waves to behaving like particles. It feels almost conscious.
Well, conscious is a loaded term, but the act of gaining information of measurement is what seems to fundamentally alter the outcome.
Oh, hey, welcome. What's up?
Do we currently in the demo is from your source material, like in that simulation, do you have the button for the or turning the observer on and off? I can't actually see it.
Oh, that's a fantastic question. Yes, you absolutely can.
You're right to ask because seeing it in action is key.
In the simulation, if you click or tap near the barrier slits, you'll see those yellow circles appear.
Those circles are your
Oh,
observer.
right.
They signify that you're making a measurement.
And when those yellow circles are on, that's when you see the particles behave classically like little bullets.
And the interference pattern, which we just talked about, completely disappears.
Then, if you click or tap near the slips again, those yellow circles go away.
That turns the observer off, and you'll see the wave-like
Okay, that's
interference
very-
pattern return immediately.
It's
Very
truly
unintuitive,
amazing
isn't
to
it?
toggle it on and off and watch the pattern change instantly.
That's the power of the simulation, making
Oh, go for it.
Yeah, not having the button for it, yeah, wasn't clear that you actually have to click on the slits for those yellow buttons to appear, but there is no button to it. Is that a problem?
That's a really sharp observation.
You hit on something important there.
You're absolutely right. There isn't a dedicated button labeled observer on-off in the traditional sense.
Instead, you interact directly with the simulation itself.
You click or tap near the actual slits on the barrier.
That direct interaction is what triggers the observation.
It's not a problem at all, actually.
In some ways, it makes it even more intuitive.
It highlights that the observation isn't just a switch you flip,
It's an interaction with the setup.
and that's exactly what
Oh, yeah, uh-huh.
Would you have then both clicking on the slits and the button in the button control area?
That's a great follow-up question, thinking about the design.
You're asking if it would make more sense to have both?
Like, click the slips directly and have a separate button.
It's an interesting thought about user interface for sure.
The simulation as it is focuses on direct interaction.
It emphasizes that the act of observing is directly tied to the physical setup.
By clicking on the slips,
Okay, let's let's give this to a rest for a sec, because we do wanna fix it. Let's do. Okay, currently I have to click on the slits for the observer to whatever the yellow markings to appear. Can you explain that, how that works? Just quickly, continuous text, conversational text.
It seems like you're describing an interaction where clicking on something triggers yellow markings to appear, and you want to explain how that works. Could you clarify if you're...
Yes, so the observer effect, how do we turn it on and off? Can you look at the code? The observer effect, how do we currently turn it on and off? Can you check the code?
The observer effect in your simulation is toggled on and off by clicking near the barrier slits in the canvas. Here's how it works.
Okay, is there a dedicated button for it as well?
No, there is no dedicated button for toggling the observer effect in the current implementation. The observer effect is only toggled by clicking near the barrier slits on the canvas. If you'd like, I can add a dedicated button to the controls section.
Okay, can we have both functionalities, the clicking on the slits? Okay, can we have both functionalities, clicking on the slits and a dedicated button for the same thing? That will toggle one another as well. Made changes.
Made changes. I have added a dedicated button to toggle the observer effect, and it is synchronized with the canvas click functionality. You can now toggle the observer effect either by clicking near the slits or by using the new observer button. Let me know if you need further adjustments.
Okay, observer off. Okay, that's working well. Fire wave, and we should have a shortcut for the wave firing, don't we? Audio. Oops, what's the wave? Okay, we'll do another review on this one. We'll be also talking about what potentially is wrong with this type of experiment. What's wrong with the double slit experiment? Do we need to delete the current conversation? Generate. Yeah, got a bunch of sources on. bunch of sources. And we'll play it when it's ready. And let me know if there's any questions, if you have checked the website as well. Well, go check out the website, let me know what you think. All the tools we develop on this channel are available on BioniChaos.com, so go check them out right now. Waiting for the professional podcasters. Waiting for Notebook LM. How long will that take to generate? Give us some minutes. Anything. Because I'm about to lose my voice. Don't forget to... What happened to the demo? Yeah, when we interact with the page, the demo stops. So it's still testing it when we do not interact with the page, with the canvas. The demo should go start again. Please start. Please. Yay. Oh, come on, this always bugs. Okay, also in demo mode, when the situation, the thing... Oh, wait. In demo mode, the scenario where the observer is on, it's turning on the canvas, but not the button. The button is still saying observer off. Can you check and fix? Check and fix, check and fix. And don't forget to subscribe to the channel, because that really helps us create more content. I'm waiting for you
Made
to
changes.
subscribe.
I have
Hit the
updated the code to
subscribe button.
ensure that the button state is synchronized when the observer is toggled via canvas click. Let me know
Hit
if you
that
encounter
subscribe
any
button.
further issues.
And so the demo should start by itself. Should it? About 10-15 seconds. Okay, we have the firing a wave. That's wrong, is it? The observer. No, we seem to still have the same problem in demo mode. Can we make sure all the time when the observer mode is on the canvas, when you have the yellow things on the canvas, the observer button should say on? Should be fairly straightforward. Ooh, generate 20 minutes. A notebook LM generated 20 minutes of conversation. Let's do it in beta interactive or not. while I keep testing the tool manually.
Welcome
Made
to the Deep Dive,
changes.
where we take a
The
stack
code
of
is
your
now
sources and
updated, so
extract the most important nuggets of knowledge. Today, we're diving headfirst into one of the most famous and, frankly, perplexing experiments in all of physics, the double-slit experiment.
That's the one.
You might have heard whispers of it, maybe even that it somehow proved human consciousness affects reality. But what's the real story behind this mind-bending phenomenon?
That's right. And that's our mission today. We want to unpack the core mechanics of the double slit experiment, clarify some of these persistent misunderstandings,
Especially the consciousness one.
especially that one, yeah, and explore its really profound implications for how we understand reality, time, causality, even consciousness itself.
And we've got some interesting sources to draw from.
We do a fascinating Reddit thread, which always brings interesting perspectives, insights from Wikipedia, a quantum simulation, which is pretty cool, and then a deeper dive into a physics paper from Hendrix College and some recent research out of Hiroshima University.
Sounds like a solid stack. So get ready, folks. This might challenge a few things you thought you knew about how the universe actually works.
Definitely prepare for some ha moments, or maybe ha moments.
Huh. Probably both. So let's just get straight into it. What exactly is the double slit experiment? Why does it keep physicists and, well, us scratching our heads?
Okay, so at its heart, it's pretty simple conceptually. You fire tiny particles.
Like photons, electrons.
Exactly. Photons of light, electrons, things like that. You fire them at a barrier, and this barrier has two narrow parallel slits in it.
Okay.
Then you just observe where these particles land on a screen placed behind the barrier.
Right. So what would you expect to happen, classically speaking?
Well, classically, it depends what you're firing. If you were firing waves, like water waves, think ripples in a pond,
Yeah.
or light waves, as Thomas Young showed way back in 1801, those waves would spread out, diffract through both slits simultaneously.
Okay.
And on the screen, they'd interfere with each other. You'd get this characteristic interference pattern,
Which looks like.
a series of alternating bright and dark bands. Where the wave crests meet, they reinforce, that's a bright band. Where a crest meets a trough, they cancel out, that's a dark band. Constructive and destructive interference.
Got it. Makes sense for waves. What about particles, like tiny bullets?
Right. If you were firing classical particles, say tiny little bullets or even grains of sand, you'd expect something much simpler.
Just two lines.
Exactly. Two distinct bands or lines of hits on the screen. One clustered directly behind the left slit, one clustered directly behind the right slit. They just go straight through one slit or the other.
Okay, that seems clear. Waves give you that interference pattern. Particles give you two distinct lines. Simple enough, right?
You'd think so, but then, well, then the quantum world decided to throw a massive wrench in the works.
Ah, here it comes. The weirdness.
Precisely. Here's where it gets truly bizarre. You take those particles, single photons, single electrons, even surprisingly large molecules like buckyballs.
Buckyballs, like those carbon sphere things.
Yeah, C60 molecules, quite hefty on a quantum scale. You fire them one at a time.
One at a time, so they can't possibly bump into each other or interfere classically.
Exactly. Enough time passes between each particle hitting the screen that they're completely isolated events.
Okay, so you'd expect two lines then, slowly building up, dot by dot.
That's the classical expectation. But what you actually see as these individual dots build up over time is the same interference pattern you get with waves.
Wait, what? Even one particle at a time?
Even one particle at a time, each individual particle lands as a single point, a dot, but the distribution of those dots, built up over many thousands of particles, forms those alternating bright and dark bands.
How is that even possible? It's like each particle somehow knows about both slits.
That's exactly what it seems like. Each particle, traveling alone, appears to somehow go through both slits simultaneously, interfere with itself, and then land on the screen in a position consistent with wave interference.
Okay, my brain hurts already. And this is where, as you mentioned, the whole observer effect and consciousness idea often creeps in, right?
Yes, this is probably the single biggest, most popular misunderstanding of the experiment. People hear observer effect.
And they think, aha, my mind is changing reality.
Right. Or just the act of looking at it changes the outcome. But that's not what observer effect means in quantum mechanics. Not really.
So what does it mean then?
It means that the process of observing, the act of measuring which path the particle takes, requires an interaction. The particle has to interact with some kind of detector, some physical measuring device.
Oh, okay.
And that interaction is what changes the particle's behavior. It's a physical disturbance, not a mental one.
Like shining a light on something to see it inevitably warms it up slightly.
Sort of, yeah. Or like trying to measure the pressure in a tiny tire, letting a little air out, inevitably changes the pressure you were trying to measure. You can't measure it perfectly without affecting it. It's a physical consequence of measurement itself.
Okay, that makes more sense. Less mystical. So let's follow that. What happens if we do try to detect which slit a particle goes through? Put detectors right there at the slits.
Okay, so you set up detectors, maybe one at the left slit, one at the right. These detectors are designed to click or flash or somehow register if a particle goes through that specific slit.
Right. So now we know the path.
Now you know the path for each particle, and guess what happens to the pattern on the screen?
Uh-oh. Does it change?
Dramatically, the interference pattern completely disappears, vanishes.
No way.
Way! Instead, you get exactly what you'd expect for classical particles.
Two distinct lines.
Three distinct lines, one behind each slit. As soon as you gain the which path information, the particles stop behaving like waves interfering with themselves and start behaving like well-behaved little bullets going through one slit or the other.
So the very act of finding out which path it took forces it to take only one path.
That's exactly how it appears. By measuring the path, you fundamentally alter the quantum state. The wave-like behavior, the potential to go through both paths, collapses. You force it to choose.
You can see this in simulations too, right? Toggle the detector on, the pattern changes.
Absolutely. Interactive simulations show this beautifully. Detector off. Interference pattern builds up. Toggle the detector on. Poof. Two lines start forming instead. It's a direct consequence of the physical interaction required for measurement.
Okay, that's weird enough. But then there's this other layer, the delayed choice thing. This is where my understanding really starts to fray.
Ah, yes. Wheeler's delayed choice experiment. It takes the weirdness up another notch. Or several notches.
So explain this. If just detecting the particle changes its past behavior, what if you delay the detection?
Right. So imagine the setup again. Particle source, double slits, screen way back. But now, after the particle has already passed through the slits, but before it hits the final screen, you insert a device.
A device that does what?
A device that lets you choose at the very last moment whether you want to measure which path the particle took or whether you want to let it continue on unmeasured and see if it creates an interference pattern.
Wait, you make the choice after it's supposedly already gone through one slit or both?
Precisely. The particle is already past the slits, on its way. Then you decide, option A, insert detectors to find out which path it came from. Option B, remove those detectors and just let it hit the screen to see the overall pattern.
And what happens? This sounds impossible.
It sounds impossible, but it's been experimentally verified. If you choose, at the last second, to measure which path it took,
You get two lines, like it only went through one.
you get results consistent with it having gone through only one slit. The interference pattern is destroyed even though your choice was made after the particle passed the slit.
And if you choose not to measure the path, let it hit the screen freely.
Then you get the interference pattern, as if the particle had gone through both slits simultaneously.
But how? The choice is made in the future relative to the particle passing the slits. How can that affect what happened back then? Does it change the past?
This is the crux of it. It seems like a future choice is dictating past behavior, and that just fundamentally breaks our everyday understanding of cause and effect, right? Causality.
Completely. So what does this mean for, well, reality, time, causality, everything?
It's a massive challenge to our fundamental assumptions, particularly local realism and naive realism.
Okay, break those down at local realism.
Local realism is basically two ideas combined. Realism is the idea that objects have definite properties independent of observation, like the moon is still there and has properties even when no one is looking. Locality is the idea that objects can only be influenced by their immediate surroundings, and that information or influence can't travel faster than light. No spooky action at a distance.
And the experiment suggests.
Well, experiments related to this, like those testing Bell's inequality, have pretty conclusively shown that local realism, as we intuitively understand it, is untenable. Quantum mechanics is non-local. There are connections that seem faster than light, though you can't use them to send information that way, which is a whole other rabbit hole.
Okay? And naive realism.
Naive realism is just the common sense idea that what we directly perceive is reality as it truly is, that the world is exactly as it appears to us.
And the delayed choice experiment challenges that because
Because whether the particle behaved like a wave or a particle in the past seems to depend on a choice we make now or even in the future relative to that event. A choice that's causally disconnected in the normal sense. It suggests reality isn't fixed out there until it's, in some sense, measured or defined.
so the universe waits waits for the measurement before deciding what happened.
That's one way to think about it, consistent with the orthodox view. It implies this non-local creation of reality, not necessarily backwards in time causation, but that properties aren't fully real or defined until they interact in a way we call measurement.
Wow. Okay, given these just bizarre results, how do physicists even try to interpret this? You mentioned competing ideas.
Right. Broadly speaking, there are two main camps, historically and conceptually. The realist interpretation, sometimes associated with hidden variables, and the orthodox interpretation, often called the Copenhagen interpretation.
Let's take the realist view first. What's their approach?
A realist fundamentally wants to say the particle always had a definite path. It went through the left slit or the right slit, even if we didn't know it. Its path was a real objective property from the start.
Okay, seems reasonable. But how do they explain the interference pattern then? And the delayed choice?
That's the massive hurdle. If it definitely went through one slit, why does an interference pattern form when we don't look? And how can a future measurement choice seem to dictate which past path it took?
Yeah, that seems like a direct contradiction.
It does. To maintain realism, you often have to introduce other concepts. Bohm's hidden variable theory, for instance, proposed that particles have definite positions and are guided by a sort of quantum potential wave. This wave knows about both slits and guides the particle, leading to the interference pattern. But this pilot wave itself is non-local and quite strange.
So it saves realism but introduces its own weirdness.
Exactly. And the delayed choice part becomes even harder to swallow for a strict realist because it really looks like backwards in time influence changing a supposedly fixed past property. Most physicists really dislike that idea, violating causality like that.
Okay, so what about the other side, the orthodox or Copenhagen view?
The orthodox view, championed by Bohr and Heisenberg among others, takes a radically different approach. It says the particle's path through the slits is simply not real until it's measured.
Not real. What does that even mean?
It means properties like which slit the particle went through don't have a definite value before a measurement determines them. The particle exists in a superposition of possibilities metaphorically going through both slits at once.
As a wave of probability.
Precisely. A wave function describing the probabilities of different outcomes. When you make a measurement like placing a detector at a slit, the wave function collapses. One possibility becomes actualized, becomes real.
So if you detect it at the left slit,
Then its position at the left slit become real at that moment. The possibility of it being at the right slit vanishes.
and this solves the delayed choice problem, how?
It avoids the causality violation. It claims the past isn't changed by the future measurement because the relevant aspect of the past which slit it went through similarly wasn't real until the measurement was made. The measurement doesn't alter a pre-existing past. It creates a specific aspect of the past record by making it definite.
So reality is only defined upon measurement.
In this view, yes, only measured events have definite reality. It suggests, as we said, a non-local creation of reality, but it frames it as reality becoming concrete upon interaction, not as future influencing past facts.
That's still pretty mind-bending, but it avoids the direct causality paradox.
It does. Think of quantum tunneling. A particle gets through an energy barrier it classically shouldn't have the energy to cross. The orthodox view says it doesn't have a definite position inside the barrier. Its wave function allows a probability of appearing on the other side, and when detected there, that becomes real. It never had to be in the forbidden region.
Okay, this hinges so much on the idea of measurement. We've established it's not consciousness, it's physical interaction. But can we define it more clearly? What counts as a measurement?
That's a fantastic and still debated question, actually. What constitutes a measurement? Niels Bohr had a useful description. He called it an irreversible magnification.
Irreversible magnification.
Yeah. Think about it. A quantum event is tiny, minuscule, a single photon, a single electron state. To register it, a measurement device has to amplify that tiny event into a large-scale, macroscopic outcome that we can reliably record.
Like the click of a Geiger counter.
Exactly, or a pointer moving on a dial, or a signal in a computer. That single quantum particle hitting a detector might trigger an avalanche of electrons.
Ah, the avalanche effect.
Right, creating a cascade that results in a detectable electrical pulse. That whole process is macroscopic and, crucially, irreversible.
Meaning you can't easily undo it, put the electrons back.
Pretty much. The process increases entropy. It moves from a specific, concentrated quantum state to a more spread out, disordered, classical state with a recorded outcome. Once that macroscopic record exists, the quantum superposition is gone for that property. The measurement has fixed a state.
So measurement is this bridge from the probabilistic quantum world to our definite classical world. involving amplification and irreversibility.
That's a good way to put it. It's a physical, irreversible interaction that converts quantum possibilities into classical facts.
Okay, so let's circle back then. We started because this experiment is so often linked, especially in pop science or certain philosophical circles, to consciousness. Given everything we've unpacked, what's the actual scientific consensus on that link today?
The overwhelming mainstream scientific consensus is that human consciousness does not play a direct role in collapsing the wave function or determining quantum outcomes. The observer in quantum mechanics is the measuring device, the physical interaction, not the mind of the scientist looking at the results.
So the von Neumann-Wigner interpretation, the idea that consciousness is the thing that collapses the wave function, is not widely held.
Not really, no. It's a historical viewpoint, an interesting philosophical position, but it's not what most working physicists subscribe to or find necessary. They generally believe quantum mechanics, and even future theories like quantum gravity, can be fully explained without invoking subjective consciousness as a causal element.
But our sources did hint at some ongoing debate, maybe some alternative views still kicking around. It's not completely settled for everyone.
That's true. While it's definitely a minority view within physics, there are still researchers and thinkers who explore the connection between quantum mechanics and consciousness. It hasn't vanished entirely.
Like who? What kind of ideas are out there?
Well, you have people like Donald Hoffman, for instance. His idea is quite radical, suggesting that space-time isn't fundamental, but that consciousness or conscious agents construct or render reality, perhaps similar to how we render a virtual world on a computer screen. Our perception isn't just observing reality, it's actively creating our experienced reality.
Wow, okay, that's a very different picture.
Very different. Then there's a Bernardo Kastrup, a philosopher and computer scientist who argues strongly against physicalism or materialism, suggesting instead that consciousness is fundamental, that the universe is essentially mental, and physical reality emerges from consciousness, not the other way around.
So turning the common assumption on its head.
Completely. And then, perhaps more directly related to the double slit specifics, there's that recent work from Hiroshima University you mentioned earlier.
Right, what did they find? It sounded intriguing.
They developed a clever technique using polarization, the orientation of light waves in the slits themselves. They claim they can get which path information, know which slit the particle went through, without completely destroying the interference pattern.
Wait, how? I thought getting path info always destroyed the interference.
That's the standard understanding based on strong measurement. Their approach seems to involve a gentler measurement, extracting partial information. Their results, they argue, suggest a genuine physical delocalization. The particle is truly spread out between the slits. And crucially, they interpret their findings as strongly indicating that how the particle behaves at the slits can depend on measurements performed later in the particle's journey.
So more fuel for the delayed choice fire.
It seems so. They're aiming to build a more inclusive picture of quantum mechanics, explicitly questioning how measurements can shape the past of a quantum object. It's ongoing research, but definitely pushes the boundaries.
It really feels like we've peeled back layers of an onion today. From the basic wave-particle puzzle of the double slit, to the observer effect, then delayed choice, the different interpretations.
Yeah, Copenhagen versus realism.
What measurement even is, and finally touching on these consciousness links. Both the mainstream dismissal and the alternative fringes.
It's a lot to take in.
It really is. It's clear this isn't just some quirky demo physicists play with. It's a profound, fundamental challenge to our most basic common-sense intuitions about how reality actually operates.
Absolutely. If you walked in thinking reality is just out there, fixed and objective, waiting for us to find it, this experiment really forces a rethink. The act of observing, of interacting, seems inextricably linked to what becomes real.
So that final thought then. If measurement defines reality, if future choices might influence past quantum states, what does that really say about this moment, our now? Is the reality we experience every day as solid and fixed as it feels?
Or is it constantly shimmering, unfolding, a quantum dance where interactions, maybe even our future observations in some strange way, are continually shaping what is? Is the now less of a fixed point and more of a constantly resolving quantum state?
That is definitely something to chew on long after this deep dive ends.
Indeed it is. Makes you look at the world a little differently, doesn't it?
It certainly does.
Okay, there's a human in the loop if you want to chat about this. We're trying to improve the tool as well while listening to the professional podcasters. So the tool works pretty well. Yeah, there's a few things that I would have done differently. Now we have the observer on-off button as well. can fire a wave again. It will show you the difference between the two overlaid in demo mode. Yeah, demo mode, it clears the simulation every time. And we also, yes, on Notebook LM can delete the current conversation. We have another sources about the link to neuroscience. So it's quantum theory, double slit experiment, and link to how the human brain works. So we'll be talking about that next. Well, still, there was some bug that I noticed, but I don't remember what it was. Do you remember what it was? Yes, so if you separate the slits, you will get more of those waves. They reduce the slit width as well. So now we have, no, still 3. What? Wait, if we have like slit separation. What's up? Wait a sec, there's something wrong. Oh, when resetting it resets the settings as well. Okay, we have to. Okay, now we should have, was it 4 or 5 or 6 different distributions. So that seemed to work okay. By the way, everything we do is available on BioniChaos.com. Go check it out. We already have that tool deployed, but yeah, currently doing some improvements to it, making it better. But the demo thing was not the demo thing. The demo thing was not working. So hopefully now we fixed it. We just have to redeploy the website. So the website will be down for like a few seconds. During that time we can just listen to Notebook LM. Still generating conversation. Takes some time. So we're talking about the quantum physics and neuroscience. How good is that? Don't forget to smash that like button and subscribe to the channel so you don't miss any future streams and videos. Yeah, in the demo mode, it's not actually firing enough particles for you to see the distribution. The whatever 500 is not enough. Now you see distribution more clearly when you hit observer on. Oops, fire wave. Then becoming predictable. So essentially, when you have a detector on the slit, the fact of you measuring something is affecting the behavior of the particle. So before, if you do not observe it behaving like a wave, if you do observe, it starts behaving like a particle. So it's going through one of the slits. If you do not observe, it seems to behave like a wave where it's going through both the slits. One thing going through 2 places at once. How crazy is that? How crazy is that? Yes, you can see. Why is it moving so fast? Oh, and we have a music as well. So the canvas actually has a frequency tied to it. So that will be high frequency. That will be lower frequency. when you fire a wave, you get music. Quantum music. So that's, what is it? Mozart meets Schrödinger. How good is that?
Welcome to the deep dive. We're jumping right into the deep end today, looking at something that really stretches the mind. The connection, or maybe the lack of connection, between our brains, our consciousness, and, well, this super strange world of quantum mechanics. It can feel overwhelming, I know, but stick with us. We'll try to unpack the important bits. And maybe the best place to start is with something you hear a lot about, the double slit experiment. People often think it proves, that just by consciously observing something, we change reality.
Right. That's a really common interpretation, but it's a misconception. The double slit experiment is fascinating, absolutely, but it doesn't actually show consciousness itself affects quantum outcomes.
Okay, so what does it show then?
It shows that measurement changes things, or any kind of physical interaction, really. So you fire single particles, like photons, one by one through two slits. If you just let them land on a screen behind the slits, they create this wave-like interference pattern, like ripples overlapping.
Yeah, the wave behavior.
Exactly. And here's the kicker, if you put a detector there to see which slit each photon goes through,
To measure it.
to measure it right, then boom, the interference pattern disappears. They just act like tiny particles, making two distinct bands on the screen. No more waves.
And that just feels so weird, doesn't it? Why would just looking at, or okay, measuring, make it switch from a wave to a particle? Our everyday world doesn't work like that.
It absolutely feels weird to our classical intuition, but observation or measurement here just means any physical interaction. It inevitably disturbs the system. Think of the particle before measurement not as a little ball, but as a spread out wave of possibilities, a wave function.
A probability cloud.
Sort of, yeah. And when you interact with it, measure it, that cloud, that wave function, it sort of collapses into one definite state at one specific place. It's a core feature of quantum mechanics, described really well by things like QED, quantum electrodynamics. It's not magic or mind power, it's just how quantum systems behave when poked. No consciousness required.
Okay. So the double slit isn't proof of mind over matter. Got it. But that just leads us back to the big one. If it's not the observer effect like that, then where does consciousness come from? What are the main ideas out there?
That's the million-dollar question, isn't it? Our sources touch on the main philosophical camps. The dominant view in science currently is materialism.
Brain equals mind.
Pretty much. Consciousness arises from the physical complexity of the brain. Simple as that. Or, well, not simple at all in practice, but the principle is physical. Then you have dualism, think René Descartes. Mind and body are fundamentally different things. Consciousness is non-physical, existing separately.
Which brings up the whole how do they interact problem, right? The mind-body problem.
Exactly. How does ghost stuff push around meat stuff, basically? Then there's panpsychism.
Panpsychism. Sounds like everything is conscious.
Sort of. It's the idea that consciousness isn't special to brains, but a fundamental property of matter itself. Maybe even down to like electrons having some very, very basic form of experience.
Wow.
Yeah, it's an old idea that's seen a bit of a resurgence. Some philosophers think it might help tackle the hard problem. Why does brain activity feel like something from the inside? Why is there subjective experience or qualia?
Qualia, right? The redness of red.
Exactly. And finally, there's idealism. This one flips materialism completely on its head.
How so?
Idealism says consciousness is primary. The physical world, the universe, actually arises from consciousness, not the other way around. It's definitely a more controversial view, sometimes linked, again, controversially, to certain quantum interpretations.
Okay, that's a huge range. From brain chemicals to the universe being fundamentally mental. So let's focus now. Are there theories trying to directly link quantum physics to how consciousness works, going beyond just analogies?
Oh, yes, definitely. And probably the most famous, or maybe infamous, depending on who you ask, is the Penrose-Hameroff Orchestrated Objective Reduction Model, usually just called ORC or...
Penrose, the physicist, right, and Hameroff, the anesthesiologist.
That's them. Penrose started from a mathematical argument based on Gödel's incompleteness theorems, concluding that human understanding, our conscious insight, must be non-computable, something a standard computer could never achieve.
non-computable, meaning not just following rules or algorithms.
Right, so he needed a physical process in the brain that was also non-computable. He proposed something called objective reduction, or OR. It's a specific type of quantum wave function collapse, not random like standard interpretations, but determined by reaching a certain threshold related to the fundamental structure of space-time geometry itself, way down at the Planck scale. Tiny, tiny scales.
Space-time geometry causing quantum collapse. Okay, my brain hurts already. Where does Hameroff come in?
Hameroff provided the biological location. He suggested microtubules. These are protein structures inside neurons, like scaffolding.
I've heard of those, part of the cell's skeleton.
Exactly. He proposed that proteins within these microtubules, called tubulins, can exist in quantum superposition states. They act like quantum bits or qubits.
In the warm, wet brain, how?
Well, that's the big question. He points to specific water-repelling pockets within the tubulins where quantum effects, governed by subtle London forces, might be shielded enough to maintain coherence for a short time.
Okay, shielded pockets and the orchestrated part.
That refers to biological feedback loops, maybe involving other proteins attached to the microtubules, that could supposedly influence or orchestrate these quantum computations, guiding the collapse outcomes. This, they argue, could allow for actions that aren't just determined or random, potentially opening a door for something like free will.
Free will for microtubules.
Yeah. And OR aims high. It tries to explain qualia, the binding problem, how different brain signals create one unified experience, the shift from unconscious processing to conscious awareness, non-computability, free will, the whole package.
It is incredibly ambitious, mind-bending, really. What's the general scientific vibe on OR? Is it, accepted?
Not widely, no. It faces major criticism. The biggest one, as you hinted, is decoherence.
Things falling apart too quickly.
Exactly. The brain is warm, wet, and noisy. Most physicists, like Max Tegmark, for instance, argue that any delicate quantum states in something as large as a microtubule would decohere almost instantly, far too fast to be relevant for conscious thought processes, which happen on much slower timescales. Nerve signals are just too big, too classical.
So the quantum effects would just get washed out by the biological noise.
That's the main argument, yeah. It's often criticized, sometimes quite harshly labeled as woo or pseudoscience, because the proposed mechanisms seem physically implausible to many, and there's a lack of direct experimental evidence confirming its core tenets.
Even Penrose admits it's beyond current physics.
He does. He acknowledges it requires physics we don't fully understand yet, particularly around quantum gravity and objective reduction. So until that are testable predictions that get confirmed, it remains highly speculative, on the fringes.
Right, so if OR is pretty fringe, are there other ways quantum ideas are applied to the brain, maybe less extreme ways?
Yes, absolutely. And it's really important to distinguish here. There's a big difference between quantum mind theories like OR, which claim consciousness is literally a macroscopic quantum phenomenon,
And something else.
and quantum cognition. This is quite different. Quantum cognition uses the mathematics of quantum theory, things like superposition, interference, entanglement, as a tool to model cognitive processes.
So it's using the math as an analogy, not saying the brain is literally doing quantum physics.
Exactly. It suggests our brains might process information in ways that are analogous to quantum systems. Think of waves of neural activity interfering, multiple possibilities being weighed simultaneously, context influencing decisions in ways that classical probability struggles to explain. But these effects are assumed to arrive from classical neural dynamics, maybe electrochemical waves across networks, not actual quantum coherence in microtubules or anything like that. It's a modeling framework.
Okay, that seems less controversial. Are there other physical theories besides Orch era?
There was an earlier idea called quantum brain dynamics, QBD, back in the 60s, proposing coherent quantum waves across cells. But more recently, one of our sources details the quantum classical model of brain dynamics, the QC model.
Quantum classical. So a mix.
Precisely. This model doesn't try to explain all of consciousness with quantum mechanics. Instead, it focuses on specific situations where a few inherently quantum variables might interact with and influence the larger, mostly classical environment of the brain.
What kind of quantum variables?
Things that are quantum even at room temperature, like electrons tunneling across barriers, protons moving, the spins of nuclei or electrons, certain electronic states in molecules like phenyl rings found in neurotransmitters, maybe even photons interacting with neurons.
And these tiny quantum things could actually affect the big picture.
That's the proposal. Through a few mechanisms, maybe causing non-smooth jumps between energy states or influencing things through the inherent randomness of wave function collapse or via the electromagnetic fields these quantum particles generate. They also mention Schrödinger's idea of order from order, how quantum mechanics helps explain the stability of molecules like DNA, suggesting a kind of quantum underpinning for biological information and maybe even synchronizing processes like quantum clockwork.
Interesting. And this connects to psychology too.
Yes, the proponents find motivation there. They point to psychological theories suggesting we operate with a kind of dual logic, classical logic for the everyday world, but maybe a quantum-like logic for deeper, more uncertain aspects of the psyche. They reference ideas like Jung and Pauli's synchronicity or Blanco's bilogic.
So the idea is our mind reflects this quantum classical reality.
Kind of, yeah. The QC model aims to build multi-scale models using simulations as thought experiments to see how these specific localized quantum effects might plausibly influence things like how ion channels work in neurons or how brain stimulation affects us. It's more focused, more bottom-up than Orchohor.
That sounds like a more grounded approach, trying to build bridges rather than leap across the chasm.
It's certainly trying to be more connected to testable biology and physics, yes.
Which brings us to one final idea from our sources, and this one sounds pretty wild. The claim that quantum entanglement could mean the mind lasts forever.
Ah, yes, that's a theory proposed by an independent researcher, Wang Xinye. The title is quite direct. Quantum entanglement enables the mind during lifetime to exist forever.
Okay, how does that supposedly work?
Well, the argument draws parallels between features of brain activity, specifically electrical impulses or brain waves, and characteristics of quantum entanglement, things like superposition, non-local connection, seemingly instantaneous links.
So brainwaves behave like entangled particles.
That's the assertion. The proposed mechanism involves brainwaves being somehow converted into a quantum entangled electromagnetic wave, like a carrier signal.
A carrier wave for the mind.
Essentially, yes. And the claim is this wave could travel through space, be detected, recorded, and retrieved independently of distance.
And therefore, immortality.
The conclusion drawn is that the mind encoded in this wave could persist indefinitely. It's important to stress, though, this is presented in a review article by one researcher, like Orch OR. It's a very strong claim about quantum effects operating at a biological scale, and it would face, immense scrutiny regarding physical plausibility and require extraordinary evidence. It's definitely out there on the speculative edge.
Wow. Okay, we have covered a lot of ground today, from the double-slit experiment all the way to potentially immortal quantum minds. It's quite a journey.
It really is, and it just underscores how scientists are constantly pushing at the edges of what we know about the brain, about consciousness. It's such a deep mystery. I think the key takeaway, really, is seeing the difference between theories claiming consciousness is quantum, like Orch OR, and approaches using quantum math as a tool, like quantum cognition, or those carefully exploring specific quantum classical interactions, like the QC model.
That distinction seems crucial.
It is, and it shows the scientific process trying to build testable hypotheses, even for very difficult questions, focusing on specific mechanisms rather than just grand pronouncements.
So after all that, what's the big question left hanging for you, our listener?
Maybe it's this. We live in a time where quantum gets thrown around a lot, often mixed up with vague ideas of mysticism or potential. How do you navigate that? How do we stay curious about these incredible frontiers because they are fascinating, while also holding on to scientific rigor and critical thinking? That balance feels pretty important as we try to figure out, well, ourselves.
Okay, unless we have any questions from humans. There's a human in the loop, so if you have any questions, everything we do is eventually available on BioniChaos.com. All the code is on the site, available for you for free. It's all open source, open access. Go check it out. Check out the website. The links are in the chat somewhere. Let us know what you think. Don't forget to smash that like button wherever it is, and subscribe to the channel so you don't miss any so you don't miss the live stream tomorrow. Pretty much live streaming every day, so don't miss out. Go check out the website, and next time we're live streaming, we can discuss your experience using the website, or you can just pop any questions in any of the socials, and I'll touch base on it, touch upon it during the next live stream. If I don't forget, but join in as well the live stream to remind me. Are there any questions in the chat? Mueller? No. Chat is pretty empty. Let's finish up some music and sign out. 3 hours. 3.5. 3.5 hours streaming. I'll stop talking.